So far, we've been content to collect and for each and print line our data because it's a fairly small data set, and we've been exploring, and we'd really just like to be able to see the results that we're creating. But in the real world, it's very likely that you're going to do computation in Spark and emit those results to another Cassandra table that can then be very efficiently queried by some other transactional process. That's a typical use case and typical architecture. So that requires that we know how to save data back into Cassandra. We're going to look at three cases, one where we've got Cassandra row objects, one where we've got user-defined case classes that we want to persist, and one where we've got tuples. So a lot like the examples we've been through so far with the Cassandra API, we're going to look at all three of those and ways to write them back into the database. And as we persist this data, we're going to be using a new table called favorite movies. Take a look at that schema. We've got a title and a release year, and those two participate in the primary key. There's a rating, there's a set of genres, which are strings, and there's a user-defined type called details. Details has country, language, and runtime in it. So we're adding a little bit of extra flair here in the schema, but this will help keep the examples interesting as we go forward. The key method that we need to write data back to Cassandra from Spark is save to Cassandra. This is called on an RDD and writes each record, each element from the source RDD into the destination table in the destination key space, optionally selecting just certain columns from the source RDD. Save as Cassandra table automatically creates a new Cassandra table. There's sort of an assumption in the API that we're going to be creating data and persisting it in interesting ways and persisting maybe transitory collections of data, so much so that it'll even offer to create the table for us. So there are elements of that API that I'm not going to dive into in a whole lot of detail right now. They're worth reading about in the documentation, but elements of that API that govern the schema of the created table. In particular, defining the key is an important thing, and I encourage you to read the documentation on that to get into it a little bit more. We're going to keep things simple in our examples here, but definitely worth digging into after you master the basics. And if you really have an elaborate table definition, you want to create a table and it has an interesting key definition, that's entirely possible. You have the save as Cassandra Table X that allows you to specify a data structure, pass in a data structure that describes the partition key and clustering key definitions and any other additional columns and their data types. Of course, you could also just create the table that you want and use the regular Cassandra CQL driver to issue that create table statement and then call save to Cassandra. So if you've got an elaborate schema, you just prefer to do it that way, completely fine. It's not an anti-pattern at all to mix and match the CQL and the Spark calls. Let's take a look at a trivial example of save to Cassandra. Now, for convenience, we're reconstituting that movie RDD. We're selecting movies by actor, where actor is Johnny Depp, and we just want title, release year, and rating. And we're going to filter only on those members of that RDD, those elements in that RDD whose title happens to be Alice in Wonderland. So not exactly big data at the end of that. It's one element. But now we can see in a very simple way, we call in those final two lines, save to Cassandra. We'll specify, as always, the key space and the table. The table is now favorite movies. That's where our output data, our processed analytics data is going to, that favorite movies table. And we'll write the title, release year, and rating columns to that table wrapped in that sum columns object. Now, details is going to be null. That's that user-defined type. We don't have any details to write yet, but that's fine. Now, here's a very simple example of persisting case class data. Now, suppose we had some Cassandra rows that were created by instantiating case classes. We looked at an example of that in the previous section. In this code here, I'm going to show you, again, just enough code for you to type in and something that you can wrap your mind around fairly easily. We'll see there's a new case class called genres info that has three fields: title, a string, release year, an int, genres, a set of strings. And in that next line of code there, we simply parallelize a sequence literal there of a single member of new genres info. So this is like an RDD created from a case class that just has one element in the RDD. And we assign it to the val genres. Now, that genres RDD we call save to Cassandra, killer video, favorite movies, the favorite movies table, the output table, and we specify some columns, title, release year, and genres. And that RDD, which was instantiated through the case class pathway, is persisted just as neatly back to the new table. Finally, with tuples, we'll do the same thing here, where I'll create sort of in a literal a new RDD from a tuple, and then we'll persist it, just so you can see how the API works with real code. We parallelize a literal sequence that has a single entry. It's Alice in Wonderland, it's from 2010. And finally, we have a value for our user-defined type. That's on that third line that says UDT value from map, and then a map mapping country to USA, language to English, runtime to 108. Those are those three members from the UDT that we defined back at the beginning of the section. Having created that new RDD, we can simply save it to Cassandra, same API, specify the 3 columns, and it gets done. And we have a value in the details column. We have a value for our user-defined type. First time we've seen that be not null. That's the basics of the Spark-Cassandra connector. We've looked at how to read data out of Cassandra, how to operate on Cassandra row objects, how to do more interesting things, a couple of different ways to transform a Cassandra row into a tuple or an instance of a class, useful for different kinds of use cases. And of course, we looked at how to save data back to Cassandra, regardless of which way we got the data in from Cassandra and sort of what it became during the process of being transformed. We could write it back out to tables. And that's a very common use case. Bring the data in, do the distributed computation on the data, and write summary results out to a Cassandra table that can then be accessed with very low latency with a typical Cassandra query. So we begin to have some pretty powerful tools under our belt now that we know something about what RDDs are and how to interact with Cassandra and just the basics of how Spark works. You're starting to get to the point where you could be dangerous. In the following section, we're going to build on those skills in some important ways. Stick with us.